Well, hello and welcome to Doc Onco's Physics. Keith Onco here. Today what we want to look at is momentum in one dimension once again. And we want to look at elastic collisions using both conservation of energy and conservation of momentum. Okay, it's not too difficult. In fact, it's kind of neat the way the conservation of energy equation boils down into a nice simple equation. In prior examples for elastic collisions, we had the before situation, right? There's my pencil here. We had the before situation, and we had the after situation. But in the after situation, I told you what one of the velocities would be of one of the objects. And it was mere guesswork on my part. I didn't really know what was going to happen to that object. But there is a way that we can absolutely know what the velocity of that object is going to be. And that is if we use conservation of energy in combination with conservation of momentum. And it's not too hard. That's the good news, right? And so we're familiar with our conservation of momentum equation, right? We've been using that if you've been doing some problems. But now what we want to do is we want to add to the mix this equation down here. And what this equation here is a combination of this equation, right, added to the conservation of energy equation. And the conservation of energy equation is, 1/2 ma va squared plus 1/2 mb vb squared is equal to 1/2 ma va prime squared plus 1/2 mb vb prime squared. All right, that would be the conservation of energy equation. And what happens is if I add this equation and this equation together, you wouldn't think you would get something nice and simple, but in fact we do get something nice and simple, and it's this third equation. Va plus Va prime is equal to Vb prime plus Vb, right? It's that simple, right? And so now what I have is I have two equations because I'm going to have two unknowns. I'm going to have an unknown of Va prime and Vb prime after they collide, right? Because I know this stuff, right? I know what's happening before they collide, but now after they collide, I'm not going to assume that I know what any of the velocities are, all right? So, and that's fair. In fact, that's life. It's not just fair. So, let's look at our momentum before they collide. Well, what do we got? We have 2 kilograms times 4 meters per second going to the right, and so we're going to have 8 kilogram meters per second from object A, right? And for object B, we have 8 kilograms times 0, so the momentum of object B is 0, so our total momentum, right, is going to be 8 kilogram meters per second. That is our total momentum. So now what's going to happen after they collide? Well, let's take a look at equation 1 first. All right. Ma Va prime plus Mb Vb prime is 8 kilogram meters per second. And that's going to equal Ma Va prime, right? And so that's going to be 2 kilograms times Va prime plus 8 kilograms times Vb prime. So we have one equation, we have two unknowns, right? So we need to do something. Well, let's take a look at our second equation. What have we got? Va plus Va prime equals Vb prime plus Vb. Well, Va is 4 meters per second, okay, plus Va prime is equal to Vb prime plus 0. So in other words, Vb prime is equal to 4 plus Va prime. Well, now I'm getting somewhere, because now what I can do is I can take and substitute this into here. All right, actually substitute the left-hand side into there. So what have I got? I'm going to leave the units out because it gets confusing with the units. So I've got 8 is equal to 2 Va prime plus 8 times VB prime. Well, VB prime is 4 plus VA prime. 4 plus VA prime. Okay, so now let's expand this. I've got 8 is equal to 2 VA prime plus 8 times 4 is 32 plus 8 times VA prime. All right, so I've just expanded these out. I subtract 32 from each side. I get negative 24 on the left-hand side now is equal to 2 and 8 is 10 VA prime. So VA prime turns out to be negative 24 divided by 10, which is negative 2.4, and it's meters per second because it is velocity. So what's going to happen to ball A here? Well, it's going to hit ball B and bounce off of it. It's going to go in the opposite direction at negative 2.4 meters per second. Well, what's going to happen to ball B then? Well, my guess is that ball B is going to go to the right. Since I know what VA prime is now, all right, and I have this equation up here, I can just plug things in to get VB prime. Well, in fact, I've got an even easier equation over here. I've got 4 plus VA prime equals VB prime. So 4 meters per second plus VA prime, which is negative 2.4 meters per second, is equal to VB prime. And so 4 minus 2.4 is 1.6. So 1.6 meters per second is VB prime. Okay, and that's how fast. So B is going to be 1.6 meters per second. And so we've been able to figure out what the velocities of both of the objects are after they collide without knowing, without being given one of the velocities. And we simply used this new equation, VA plus VA prime equals VB prime plus VB. Rather simple equation. It just allows us to take and substitute in one value into our conservation of momentum equation. Well, that's it for using energy and momentum for a totally elastic collision. Remember, this only works for totally elastic collisions where you can use this equation. You cannot use it for an inelastic collision. Hope that helps. Have a great day.